NASA's constellation of tracking and data relay satellites, TDRS, are the critical link for continuous space communications. But it wasn't always this way. Before TDRS, NASA relied on a web of ground-based tracking and communication stations located around the globe. These ground stations use large antennas to receive early transmissions from space. The different orbits of these spacecraft determine the locations of ground stations, with the majority being centered around the equator. Sometimes even ships and planes that house antennas were used to fill in holes of coverage between spacecraft and user control centers. During this period, these early spacecraft only had a few moments to transmit their data to each station as it traveled on its orbit, passing from horizon to horizon. In an attempt to increase visibility with the ground, the number of these ground stations around the world multiplied. As time passed, these networks evolved and merged, but they often suffered from a variety of challenges such as regional weather and political instability. With the advent of the shuttle program, NASA began to see the need for an improved solution. The TDRS project was established to develop a constellation of satellites that would be designed to route data between the user spacecraft and the ground for critical NASA missions in low Earth orbit. The 9 TDRS spacecraft that have been deployed since 1983 have transformed the way NASA communicates. Each TDRS spacecraft is placed in a geosynchronous orbit, giving them a fixed line of sight with one of the TDRS ground stations. Today, TDRS spacecraft relay data between Earth-orbiting satellites and the dedicated TDRS ground terminals 24 hours a day, 7 days a week. 3 TDRS ground terminals provide a constant connection between the TDRS constellation and the user spacecraft's data processing facilities. 2 of these stations are located at the White Sands Complex in New Mexico, and the third is located in Guam. Together, the ground stations in the fleet of TDRS spacecraft provide 100% global communication coverage, ensuring that data from dozens of Earth-orbiting missions is delivered on time, every time. TDRS provides a vital service to Earth science missions studying the evolution of Earth's climate and researchers postulating about the future of the Earth system. These missions are delivering data in real time about Earth events and processes vital to human civilization. TDRS communicates with launch vehicles as they send missions on their journeys of discovery. TDRS tracks their locations as they leave the launch pad, ensuring that engineers on the ground know that the vehicle is on the right course and is functioning properly. TDRS provides critical voice and video support to NASA's human spaceflight endeavors, including ongoing support of the International Space Station and its critical resupply vehicles. TDRS supports space science missions that investigate the farthest reaches of space, cataloging gamma-ray bursts, the birth of galaxies, and the early history of our universe. Through them, we can learn new information about the scope and scale of the cosmos. NASA is getting ready to replenish the fleet by adding the first of 3 new spacecraft to the constellation, TDRS-K. TDRS-L and TDRS-M will be launched in the coming years and join the constellation, ensuring that the critical lifeline of space-to-ground communication support will be available for many years to come.